Steve, come on stage. Thank you for being here today with us.
Okay, great. Fantastic to be here and fantastic to just cycle not too long to the venue and to be here with you all in Amsterdam. So I'm going to talk briefly today, so it's only half an hour, about vector search at Elastic and what we're doing in this space and why. Okay, so an overview of the talk is initially I'm just going to go say, why would you use vector search? What are the use cases for it? Then I'm going to dig a bit into how we use vectors, how can we actually return relevant results and so on with vectors and in terms of vector similarity. And then I'm going to just touch on how we're doing this at Elastic and how you can actually sort of get your hands on this technology and start playing around with this technology in the Elastic stack. So the first thing is why would you want to use vector search? Elastic is built on sort of TF-IDF indexes, BM25, and keyword searches, and that's really good for a lot of use cases. But increasingly, we're seeing things like people expect the search on their e-commerce website to work a bit more like Google and to actually understand the user's intent and the context behind what they're searching for, as opposed to just the keywords. So, can we search a bit more semantically rather than just in terms of the keywords? Also, there's multiple data types that people are ingesting into Elastic and want to search across. So, historically that's been mainly text, but now people also want to combine text search with image search and also potentially other media types in terms of search. So we need a bit more flexibility in terms of the search space we can actually search across. There's then, different contexts and domains may want different results. So, for instance, if I'm in the pharmaceutical domain, the types of ways I actually come up with relevant results can be different from e-commerce and so on. And so, how can we sort of embed context and some domain specificity in terms of our search capabilities? And then finally, everyone wants the relevant results at the top. At the top of that first 10 pages. So how can we, give you the most relevant results possible? And what I'm going to show is using vector search, we can potentially move towards some of these goals. So, the first use case I'm going to talk about is text matching, and I'm going to sort of talk at a very high level like this, but there's actually quite a lot of complexity in terms of going about implementing this, and lots of rat holes you could run into in terms of looking at taking models out of domain and using those in a different domain and so on. And I'm happy to talk about those afterwards in the Ask Me Anything booth. But one of the key use cases here is that often when you see a search query, you don't necessarily just want to match on the keywords in the document or even sort of the stemmed words in the document. You want to match on really sort of the intent of the user. And if I'm searching for a particular context, you want to try and match that context as opposed to just the words. And sort of a really concrete example is if I search for how to set up Elasticsearch ML meaning machine learning. And really, what I want to do is return documents that are based on sort of my intent here. My intent is to find documents that help me set up Elasticsearch ML. And sort of, if I look at the different things that involves, that potentially involves understanding how I configure Elasticsearch ML, how I install it, how I get started with it. The context is probably, the documents on the elastic.co website. ML is a synonym for machine learning, and that technology, Elasticsearch ML originally came from pre-alert and anomaly detection and so on. So ideally, you want to sort of have a search space that sort of encompasses a lot of that context when you're searching for that particular thing. So let's have a look at how different things do it. And as I was saying, in this case, I'm comparing Google to keyword searches. in terms of keyword searches, this is probably a bit small at the back, so I'll go through it. This is actually the key. We actually indexed the documents on the elastic.co website, and we didn't use a lot of tuning in this case, but we actually have some results here that are based on keyword matches. And there's documents which describe things like sizing machine learning, a really specific custom aggregation for machine learning jobs, and some other sort of things that we've picked up. And also, like the final one there, that was talking about deployment templates, and it's not really related to machine learning. And the words that are highlighted there are sort of very much the keywords that we put in there, but the how to set up hasn't really been translated into like configuration or installation or those sort of intents that I'm trying to put in there. So it's returned some sort of relevant-ish results, but it's not great. So and this is sort of like Google, and obviously Google have a massive advantage in terms of the amount of data they have access to and click-through rates and so on. But the results here are like seem to be very much based on what I'm looking for in terms of machine learning settings in Elastic, setting up machine learning, getting started with machine learning, and getting started with anomaly detection and so on. And also the words they've highlighted there, which are sort of matching the query, are not just the keywords, but the sort of synonyms and other context that they're highlighting there. So us moving from traditional sort of keyword search, we would like to move in this direction, and vector search is one of the tools that we've got to help us move in that direction. Another use case is sort of an e-commerce website where we're searching for garments or particular articles, and you see here that if I'm searching for a blue t-shirt with stripes, the results aren't really blue t-shirts with stripes. In fact, the results are based on matching the keywords in the set of fields in the documents there, which are sort of the description and the name of the item and so on. And in fact, there's a mislabeled item. That dress there is a mislabeled item that's returned as at the top there. And if you think about like what would be a really what am I trying to do here as a user? Like, what is the best user experience here? I'd like to return things which are similar to that, or synonyms, or in the same context as that textual thing. So I might want to return navy shirts as well, or shirts with lines as well as stripes and so on, and have some context around that. But I also want some context around the images that are returned. Because visually, it's really easy to say, well, these aren't t-shirts with stripes. So is there a way of us also returning t-shirts with stripes, blue t-shirts with stripes, and by actually understanding which images correspond to that text? And so, this is actually sort of an example. I'll give you this demo later, but this is sort of a list. This is sort of a set of results we've returned from a vector search on Elastic, which gives a lot more relevant results in terms of most of the t-shirts there are sort of blue with stripes and so on, and a bit more in line with the context and the intent of the user in terms of searching with that. And that's sort of a great use case for vector search. So there's some use cases. Now I'm now going to go into sort of a bit of a conceptual overview of vectors and what we do in terms of machine learning models and how we compare vectors and so on. So fundamentally, the premise and really the basic thing we're doing here is we're taking your data and we're creating these vector representations of your data. And we're using these machine learning models to do that. And really what we want to do is try and use this machine learning model to capture the aspects of those documents and the data in these vectors. And if we're using text, if we're trying to find a vector that represents a textual document, we might use an NLP model, a large language model. If we're using images, we might use a neural network and so on to create these feature vectors. And the great thing is there's been so much development in these spaces recently. There's so much opportunity to use these type of models, and the maturity of these models is significant now in terms of your ability to use them. But fundamentally, we're taking these documents and converting these to vectors, which will give us a space that we can search across that's different to the keyword text space that we're searching across now. Now, these aren't my slides. Someone gave me these slides, and I found this one a bit difficult to go through. But effectively, what we're thinking about is like, how many dimensions does a vector have? And the more dimensions it has, potentially the more descriptive it is in terms of understanding like the exact context or the aspects of the particular thing we're describing. And typically, if we're using these machine learning models, the vectors are a couple of hundred numbers, like 512 numbers or 256 numbers, and so on, depending on the model. And basically, those numbers actually describe very well those particular items. And one thing here is that we're not then doing an exact match on the vector like we would on a keyword, but we're trying to find similar things by doing effectively something a bit similar to a cosine similarity across two vectors to see how far apart they are. So the overall process that we're using here is we're taking the data on the left-hand side. We're using a machine learning model to create these embeddings, which are the vector representations, these dense vectors that represent the data on the left-hand side. And then we're then putting that into Elasticsearch. We then get a query, and we use the same model to create a vector representation of that query, and we look at what vectors in the database, in terms of this data, are close to that query vector, and that gives us a set of results. And in the middle there's effectively a nearest neighbor approach, which allows us to very efficiently manage extremely large numbers of vectors and return in very quickly the closest vectors using this approximate nearest neighbor technique that we've got in Elastic. And so this is sort of like the summary there, where we're taking the query and we're comparing it to the vectors. And in this case, we can return the similar vectors. And in terms of the relevance, it's basically how similar the vectors are in terms of returning the search relevance. Okay, so vector search with Elastic. So you think about like, what are the use cases for this? I think what I'm trying to go through is like how you actually sort of get started with this, and then I'll go into a demo to actually show you how we can do this. The first thing is we think about like how are you going to use this? What's the use case? Is the use case you want to have better textual search with keywords? Is the use case you want to be able to take a textual search and match a set of images? Is it that I've actually got an image and I want to find similar images? Or there's a whole host of use cases. And what we're trying to do is provide you with recipes and also shrink wrap these use cases to help you. Because as I said early on, there's a lot of blogs and stuff which say you just take, say, a BERT model, do some transfer learning on MS Marco, and you get this in-domain model. You can then apply that to everything. And generally, you get worse results than just keyword search by doing that. And so we're going to provide recipes in terms of how you can do that in a lot more effective way that can work in a more sort of general purpose way. In Elastic Cloud and Elastic since sort of the 8.x releases, we've got the ability to store vectors. We've got the ability to do vector searches and to do inference using machine learning models and PyTorch models to do this. And then there's a whole host of machine learning models that you've got access to that you'll be able to embed in your application. And then you can actually when you do the actual search, you do it in a slightly different way to a conventional search. So, this is, again, at the high level. We're taking the source data, we're putting it into Elasticsearch, but instead of just posting the doc, we're actually posting an embedding, a vector, which actually is, in this case, the embedding represents the text in description. And we're then doing a search, which is a search not across just keywords, but a search across that vector space as well, to help us provide a better semantic search in terms of matching that text. So, in terms of the steps for doing that, the first thing is we need to get a machine learning model in the Elasticsearch cluster. And under the hood, what's going on here is that Elasticsearch is written in Java, but we've actually got all the machine learning components are mainly written in C++, and we've actually got PyTorch libraries there, which will allow you to embed PyTorch libraries. So if you've got TensorFlow libraries as well, they're often transferable to PyTorch as well. So we can actually simply load these models into an Elasticsearch cluster, and there we can manage it. We can actually also auto-scale it and distribute it and in the cloud and so on to make that whole aspect of managing these models easy for you. And the thing on the left there is actually Hugging Face. So those of you who are familiar with the space, that's just a model hub that stores a load of models, and there's a lot of really good models in there that you can use for lots of different things, and you can upload those simply using this Python library called ALAND that we develop as well to help you upload that model into your Elasticsearch cluster. Then, typically I'd be taking the source data and just indexing it. But in this case, we can actually use, now we've got this Elasticsearch, we've got this PyTorch model in your Elastic cluster, we can use an inference processor to actually automatically create the embedding and add the embedding to the document as well. So effectively, we take the documents, we run them through this inference pipeline, and then we have the document with the embedding in it. And then finally, when it comes to doing the search, we've got different options in terms of doing the search. So typically, you'd do just a keyword search, but in this case, there's actually an additional clause here, which is KNN, which is the approximate nearest neighbor search, where we're searching for things which are similar to summer clothes, but also similar to this query vector that is related to the embedding there. And in 8.6, we're actually making this even easier, where we're actually doing the inference automatically in a single call that is going to make this easier. Now, one really nice thing here is that's different between Elastic and some other sort of databases in this space, is that we can actually use all the power of Elasticsearch filtering and in conjunction with this vector search. So you can combine filtering and queries and so on, and all the richness we have in those languages with vector search to give you the most appropriate results at the end of it. Okay. And and finally, as you saw in that, we can just search the vectors, but we can also search, use BM25 scores as well, and combine these to give you sort of the best of both worlds. And in fact, in Textual Search, one of the things we're developing is a way of combining these called reciprocal rank fusion, which will allow you to actually combine in a fairly general purpose way with not a lot of auto-tuning of tuning of parameters and so on to get actually a better result out of the box than BM25 for Textual Search. Okay, so I'm now going to go into a demo. And the demo is similar to the use case I presented there, where I've got this set of documents from an e-commerce site. And you see here, I've got images and various fields describing these items. Now, I might want to search for blue T-shirt with stripes. And if I search for that, then I'll get a set of results. These results are basically based on a textual search across all the fields in this case. And you can see that it's not great. This is sort of similar to that initial slide I put up, where you've got a set of things that match that, but they don't actually necessarily match what I'm looking for. You might also have users going into your website and searching in Dutch or other languages, and again, there's no sort of translation applied. It's just you're searching again just for those keywords in Dutch. We're not translating them in those cases. We're just doing a match there. And so the word blue Blau isn't in there, so we're not getting, we're getting even worse results. And you might even have users who come in and search in Japanese. In that case, we're matching T, but we're not matching anything else there, so it's not a great experience. So how can we improve this experience, and how can we relate a textual search to an image? Now, the cool thing is there's some really good models out there to do that. One of them that I'm going to use in this demo is a model from OpenAI called Clip. And what they've done there is effectively they've taken 400 million images, labeled images, and they've created a model that effectively can match text to images. So effectively, they've created this sort of really complex neural net that has encoded in it the ability to take text and also variants of text. So it's actually using a Google BERT model as well as an image encoder as well to create this model that embeds all that sort of understanding of how images and text are related. Now, the really cool thing about that is you can then use it with a piece of text, and it will return an image with it. And another thing that I think is fantastic in this space is this model was trained on 400 million images. It took 30 days on around 600 GPUs. It cost $1 million in AWS to train. And then they've given it away for free on an MIT license, so you can just use it commercially, use it in production, and it's fantastic. And I can just run it on my laptop as well, and do this type of thing I don't need sophisticated hardware. I can actually do a lot of the problems just on normal CPUs as well. So, it's fantastic you've got access to these type of models, and I can just basically, again, this is in Hugging Face, so I can just simply upload it using ALAND into my Elasticsearch cluster. And in this case here, I've uploaded it into my Elasticsearch cluster, and you can see that I've got a deployed model in my Elasticsearch cluster. I can test it with something. And you see that basically, when you put a bit of text in, you get a vector out. And what I've got is a set of embeddings in here that are, effectively these documents. But I've also, as I ingested these documents, I actually created vectors for the images as I embedded this using this Clips model as well. Yeah, so effectively, what I can do is I can do a vector search for that text, effectively the vectorized version of that text with these image embeddings, and hopefully return images which are more similar to the text. And the cool thing about this model, it's in 50 languages. So you can actually you can do searches in these different languages, and it will return similar images in that language context. In that language context as well. So if I want to do I'm just showing you vectors here, which isn't the best demo, but I'll show you actual visuals in a minute. But I can do inference in different languages, and it will create vectors there. So if I do a search, and this is like a nearest neighbor search here, and I'll show you this in the UI in a minute. This is a set of results from doing a vector search for blue T-shirt with stripes. And you can see that here are my results. And the first result is a maxi dress. Second result is that, which seems a bit strange. But what I can actually do is I can actually do that search here. And this is the set of results that you get. So from doing that textual search, this is the set of relevant images that have returned by using that model. And I think, in terms of the user intent, that looks actually pretty good in terms of what we're trying to do, and sort of where we're going in terms of doing that. And so, this sort of opens up the opportunities to not only do potentially, searches across different across text semantically, but across different media types and so on. And, hopefully it's sort of beneficial to some of your use cases. Okay, and then just finally, one of the things that we're doing is this is sort of a really active part of development. So, one of the things that you might have noticed there is I sort of did the inference, I got the vector, I cut and pasted that into the query. That's all pretty messy, but we're actually making that a lot more shrink-wrapped process. Eventually, we're going to add that to the search endpoint directly. At the moment, in 8.6, we're actually adding this new semantic search endpoint where you actually put the query, it creates the embedding, and returns the relevant results, and so on and so on. So that's a really active area of development. In addition to that, we're actually doing some good sort of academic work in terms of trying to shrink wrap the best sort of recipes for you to get the value out of this type of technology, as I mentioned earlier. In particular, we were doing a lot of benchmarks across a lot of different search relevant databases and trying to work out what are the most effective methods and what are the most effective methods for the Elastic Stack. And that's all something that we're going to shrink wrap and hopefully release to you very easily in enterprise search and also as a toolkit for you as well. Okay, so just going back to the search, there's some examples of projects that people have used this for at the moment, and it'd be great to hear a bit more. I think one thing is that there's obviously like a temptation from our marketing department to say you can now do everything because you can do vector search, and there's obviously quite a lot of know-how you need at the moment to do some of this. And over time, we're going to make that a lot more straightforward for you, and hopefully provide a lot of real examples of how you can do this. But it's available now, and certainly the demos I did today in terms of being able to embed models, to be able to search across vectors, to be able to upload PyTorch to Torch and so on is there. And it'd be great to hear about your use cases and how you find this valuable in your environments. So thank you.
Thank you, Steve.